So the first thing I wanted to do on the Firebird was finish up the wiring. I believe it was a couple of weeks ago that I chose all the electronic components that I'll be using and began wiring the ESC. Now I was ready to add a connector for the battery and wire in the servo. I started by cutting all the wires that I'll be using, and I soldered the battery connector onto the ESC. In order for the receiver to fit where I wanted to mount it on the chassis, I needed to trim down the pins. I will also solder the wires directly onto the pins. I needed to extend the length of the wires on the servo in order for them to reach the receiver. Using a smaller gauge wire would have been ideal, but this was the smallest I had on hand. After everything had been connected, I once again did a quick test to make sure everything is functioning as it should. It's not the cleanest setup in the world, but it'll get the job done. Next, I wanted to move on to the front suspension and steering. I started by sanding the front wheel hubs, and I used a bit of Model Master steel paint to make them look a bit like brake rotors. Next, I wanted to figure out how I was going to make the steering system. I started by positioning the steering servo in different areas around the front to figure out exactly where I wanted to place it. The steering servo is quite large in relation to the car, however I figured out a way to fit it in so that only some very minor modifications to the chassis will be necessary. Since the motor sits quite low, I will need to have it sit fairly far back in the car in order to have enough room for the steering linkage, which shouldn't be a problem. After brainstorming some designs, I came up with this simple piece that will easily mount to the chassis and has a mount for the servo and idler arm. The piece sits great on the front of the car, and only some minor modifications to the chassis and body are needed for it to fit. I cut some small pieces off of the chassis where the sway bar would mount on a full-size car and sanded the surface smooth. Earlier when mocking up the front suspension, I noticed that I was getting a bit of negative caster angle, which is certainly not desirable, especially on a drift car. To fix this, I modified the design of the steering knuckle so that the lower strut mount is placed closer to the front of the vehicle, which gives the car a bit of positive caster angle. I can also modify the position of the upper strut support to adjust the caster angle as well. I'm going with a linkage steering system, similar in design to how the full-scale steering system looks. The first thing I did was mount the idler arm and pitman arm to the center link. Once installed, I mounted each tie rod end to the steering knuckles. I also glued the magnets to the front wheel hubs and front wheels. After gluing the magnets, I wanted to mount the hubs to the knuckle by first installing the bearing and then a screw and washer that holds the hub in place. In hindsight, this would have been a bit easier to do before I mounted the K-member to the chassis, but everything went on without too much trouble. I also installed the springs. After doing a little bit of sanding to the servo mount to accommodate for the slight angle of the chassis, I glued the mount in place and connected the idler arm. Next, I installed the servo. I just glued the pitman arm to the servo since the splines were very worn. With all the steering components installed, I did a quick test to make sure everything was functioning as it should. And finally, I went ahead and glued the receiver to the chassis. With the steering installed and everything wired, the only major thing left to do before taking this car for a test drive is to install the motor and drivetrain. Nearly all of those components have been printed, and it's just a matter of getting them installed. I started by assembling the motor mount and gear assembly. As I mentioned in the previous video, the shaft of the motor sits a bit too high in relation to the axle to simply run a drive shaft directly from the motor to the rear axle. So this setup will ensure that the drive shaft sits low and flat in the vehicle, and the slight gear reduction will also provide a bit more torque. I started by installing the pinion gear onto the motor, which I simply press fit onto the shaft, and after that I secured the motor to the motor mounting plate using two M1.6 machine screws. Next, I installed the lower spur gear. Here I'm adjusting the position of the motor to ensure that there is a slight gap between the gears and that they can turn freely without any binding. And here's a look at the finished assembly. I made sure that the motor was operating smoothly, and I applied a little bit of grease to the gears. Next, I wanted to install the socket for the drive shaft to connect to. Now I wanted to test fit the motor mount assembly onto the chassis. The only modification I needed to make to get it to fit was to remove some material from the factory transmission crossmember. I won't be utilizing this crossmember, but I'm going to keep it in place, so I only removed enough material so that there was sufficient clearance, but I did not remove it entirely. With the motor mount assembly able to sit how I want it, I marked the position of where I needed to drill the holes. To create the pilot holes, I held a pin over a flame for several seconds and pushed the hot pin through the plastic. Then I drilled the holes out to the correct size. Finally, I secured the motor mount to the chassis using 2 screws. I'm reusing a drive shaft that I had already, which is a tad bit too long for this car. This drive shaft uses a spring to apply outward pressure to each end, which helps keep it in place and makes it easy to remove. However, this drive shaft is quite worn, and I'm afraid that the 2 sections might slip, so I simply adjusted the drive shaft so that it was the correct length, with just a little bit of wiggle room for when the suspension moves up and down, and I glued the drive shaft at that length. And with that complete, the drivetrain is now fully installed. The motor sits back further than where it would be on a full-scale car. I did this because I wanted the motor to sit as low as possible and to ensure that it wouldn't collide with the steering linkage. I've tested the interior and ESC with the motor in this position, and although it's tight, everything fits well. With everything installed, I propped up the chassis and tested to ensure everything in the drivetrain and axle is functioning correctly. Unfortunately, there's a lot of wheel wobble. This is caused by the wheel hubs having some damage and being bent when I was using this axle on a drag car. The grippy tires and high torque motor took a toll on this axle's components. I've since redesigned the hubs and axle assembly, and I'm anticipating this new design will be able to handle the torque far better than this design. I will either be rebuilding or replacing the axle on this car, but for just some preliminary test drives, this axle in its current state will do just fine. I may also add a torque arm at some point to eliminate the axle twist. Next thing I did was install the struts. For now I figured I'd just glue the upper strut mount to the underside of the body. This is just a temporary setup. I have a much better permanent plan in the works, but I just wanted to get this car to a state where I could do a quick test drive and see how well the struts would function. I did my best to make sure the struts were mounted symmetrically. After that, I cut the shafts and glued them to the knuckle. After that, I lubed the inside of the strut and mounted the body to the chassis piece. Like I said, this is just a temporary setup. I've got a better solution in the works, but with that installed, the car is now able to be driven. Even with the bad rear hubs, poorly positioned struts, and completely untuned suspension, I couldn't resist this opportunity to test out this car just to see if this crazy build will drive and maybe even drift. It turns out the car actually drives quite well. The motor provides lots of torque and plenty of speed, the steering felt accurate and responsive, and the handling seemed decent, all things considered. I'm very pleased with where the car is at right now. It's a blast to drive, and I think there is potential to make this into at least a somewhat decent drift car. Obviously, if all I cared about was drifting performance, I certainly wouldn't be messing around with a 1/24 scale Firebird model kit with a straight axle rear end, modified McPherson front suspension, and a linkage steering system. This build incorporates a balance of making the car look and function as similarly to the full-scale vehicle it's replicating as possible, while also making the performance as good as possible within those confines. With that said, I've identified a lot of things that I want to do that I believe will greatly improve this car's ability to drift. One thing that I was able to do during these tests was add a little bit of weight to different areas of the chassis and see how the car responded. This car only weighs a little under 4 ounces as is, and the weight is fairly evenly distributed throughout the car, so just placing a little bit of weight in the front or rear of the car had a dramatic effect on how it handles and drifts. There are 3 major things that I want to address moving forward on this car. The first is the motor mount. The design is fine, however, the heat from the motor has slightly deformed the motor mount to the point where the back of the motor is resting on the K-member. The solution for this is easy. I just need to remake this part using a more heat-resistant material. I'll start by printing in a more durable, heat-resistant resin. However, if that fails, I'll machine the part from aluminum. The other two things are going to be a little bit more involved. As I mentioned, I need to do some work on the axle. I had a lot of trouble getting the car to drift while filming, and I figured out that the rear diff is no longer locked. I'm currently in the process of prototyping some rear axle designs that will be made available for sale in the coming months as a part of the kit. So more than likely, I'll just be installing one of those axles into the car, rather than continuing to mess around with this one that's already in it. The last major thing is the suspension and structural rigidity of the chassis. The upper strut mount I'm going to be installing should help with the alignment and allow for a little bit of adjustability, which will definitely help. I also think I need to modify the struts a little to get some more travel, and I need to lower the rear end a bit since there's too much rake angle right now. I'm also going to address the chassis' flexibility by adding some reinforcement to stiffen it up.